In 2013, at the Georgia State University, astronomers discovered what could well be the smallest star in the universe. About 8,000 times dimmer and only 8.6% as wide, this star could actually fit inside the planet Jupiter. And it's not far away either, only 42 light years away from us. But it's not like scientists declared this little starlet the smallest after measuring every other star in the universe, obviously. They think it's the smallest star because it's as small as a star can get and still be considered a star. See, if you look around the galaxy for smaller and smaller stars, you eventually run into a problem. After a while, you start running into brown dwarfs, so-called failed stars that weren't able to sustain nuclear fusion. These objects are so cold and dim that they're considered substellar objects, rather than actual stars. And ultimately, it's the mass of an object that determines whether it's a brown dwarf or a regular star. The problem is, the mass of these objects can only be measured directly through their gravitational interactions, like when two of them happen to be orbiting around their common centre of mass. So instead, one clue scientists use to figure out the identity of these objects is to look at how hot they are. In the case of stars, for example, we know that the higher its surface temperature, the more mass it has, because most of that mass is its fuel. And so, by extension, less massive stars have lower temperatures than bigger ones. But more importantly, the fusion reactions that happen inside stars keep them at a constant size, temperature, and brightness for a really long time, up to trillions of years for small stars. But for brown dwarfs, it's the opposite. They lack the sustained fusion necessary to maintain such temperatures, so a brown dwarf with more mass will be hotter for a while, but will cool off and dim down extremely quickly. So when you're scouting out low-mass objects, the trick isn't telling the difference between a cool old star and a warm young brown dwarf, because both will be the same size and have about the same temperature. And this brings us back to our smallest star. Because both small stars and brown dwarfs are more than 1,000 times fainter than the Sun, we can only see them if they're really close to us. So the Georgia State team limited its search to our solar neighbourhood, the tiny fraction of the galaxy that's closest to our Sun, and they identified 63 very faint objects, determining the diameter and temperature of each. And the object that stood out the most was the tiniest one around, with a surface temperature of around 2075 Kelvin. Temperature, size, and brightness of the object were all right on the limit between a cool, low-mass star and a young, hot, massive brown dwarf. It was almost too close to tell. But then there were other factors that the scientists considered. One was simple probability. Basically, the longer lived an object is, the more likely it is that we'll find it. Since stars keep burning long after brown dwarfs have fizzled out, chances are that this warmish object was a small star. Another factor is that all the objects in our neighbourhood are at least several billion years old. So, all the brown dwarfs around here should have probably burned out by now. So you put all these facts together and the most likely answer is that this object is a really old, cool star. And now astronomers are fascinated with their new little friend because it might finally help them figure out how best to tell a star from a brown dwarf. We don't exactly know what the mass limit is that distinguishes between a small star and a brown dwarf, for example, but based on the temperature and diameter of this little guy, astronomers think that that threshold might be somewhere between 6% and 8% of the mass of the Sun. So for now, this little star with the big name turns out to be the smallest a star can be, earning it the title of the smallest star in the universe. Thanks for joining me for SciShow Space. If you'd like to learn how we can keep exploring the universe together, then go to subbable.com/scishow. And don't forget to go to youtube.com/scishow and subscribe.